Hello, everyone, and welcome to the Climate Dialogue Winter Speaker Series being hosted by the Sustainability Office of the University of Washington at Bothell and Cascadia College. Tonight's event is based on our speaker series. The theme of this year's speaker series is how is climate change affecting agricultural and food systems? As I said, the UW Bothell Office of Sustainability is one of your hosts tonight. You can contact us at the email on the slide. You can also follow our Instagram to get all of our updates at UWB Sustainability. You can also join our student club if you're a student at UW Bothell. And we also have some upcoming events for students.
Hi, everybody. I'm Stefan Clausen. I'm the Assistant Director of Sustainable Practices at Cascadia College. I'm the counterpart for Rachel, and we manage our events and efforts together jointly, in a sense. Our Sustainable Practices offices hosts a bachelor's degree in Sustainable Practices at Cascadia College. And if you have any information or want any information or have any questions about our programs, you can find them either at our Instagram or by emailing us. We're a joint campus, so we're proud to, showcase some of the things we've managed together, from these sort of climate dialogues and events to much of our grounds, which is one of the more impressive grounds for campuses in the nation.
Well, it is my honor to introduce tonight's guest. Carrie Brausieck is a senior natural resource specialist at Snohomish Conservation District, and she is an agroforestry professional. So Carrie's talk tonight will focus on agroforestry. Agroforestry is a multifunctional land use that integrates trees on working agricultural lands. A growing body of science is showing the potential of this land use for climate change mitigation, adaptation, and other global planetary issues. So it is my honor to welcome Carrie as our speaker tonight.
Thank you, Rachel.
And then you should be able to share your screen.
Great. All right. There we go. Great. Okay. Well, thank you for having me. And as Rachel said, I'm an agroforester and a senior natural resource specialist at Snohomish Conservation District. I currently run an agroforestry program there, and we do a lot of education and outreach around agroforestry, and we are also busy planting a lot of agroforestry practices around the Puget Sound. So in Western Washington, we're getting a lot of agroforestry on the ground on our farmlands and working lands. And I am also the co-founder of Agroforestry Northwest. So if you are interested in agroforestry, or if you have more interest after this evening's talk, please check out this group and this website. This is a great local source for agroforestry information. A lot of the information around agroforestry that you can find is from the Midwest or from the East Coast. And so this is a new group that is actually focusing on our region and regionally specific practices and information for adopting agroforestry in Washington State and Oregon. So definitely check that out if you have any further interest. And to just give you all an idea of what I'm going to cover this evening, first, what I'm going to do is set like a high-level context of a snapshot, if you will, of where we are globally and some of the global challenges that we're facing as we move into the coming decades. And then I'm going to talk about agroforestry and what that is. This may be a term that you've heard before, or maybe you've read some articles. I talk to a lot of folks about agroforestry, and there's still a lot of misinformation or misunderstanding about what agroforestry is. So we're going to all get on the same page, talk about what this land use really is, what its principles are, and then I'm going to link the two. I'm going to link agroforestry to this broader context that I've set. So, and hopefully we will have time for questions as well. So just to start with here, these are what are known as the 9 planetary boundaries, as put forth by Johan Rockstrom back, I believe, in 2009. And this graphic that you see here has been updated as of 2020. So what this group did, and by the way, this gentleman has an amazing TED Talk about this. So if you have any further interest in what these 9 planetary boundaries are, his TED Talk is really worth checking out. But essentially what they did is they came up with these 9 functional boundaries that need to be functioning relatively well or normally for us to sustain life as we know it today on our planet into the future. And so you can see the 9 boundaries here that they've come up with. And then they are constantly collecting data and doing research to update the information that they gather here and that they display in this graphic. So what we have here are the 9 boundaries, and then within these boundaries, we can see that there are these zones. And in this green space here, I'm pretty sure you can all see my mouse moving around. This is what's known as the safe operating zone. This is where these functional areas are functioning well. We have, good data, things are sustainable, and life is good. And then you can see we cross out of this zone into this these light orange colors. And this is a zone where now we're starting to see some dysfunction in these boundaries, in these functional areas. We are starting to notice some increasing risk, some uncertainty, and things are starting, to not go well. And then we have a third zone, which is represented by these dark orange colors here. And as we get into these zones, we now are facing some real uncertainty, some great dysfunction within the system. Potentially, we've crossed some tipping points. We're in real high risk territory here. And so, yeah, that's what this third zone represents. And as you can see, too, all of these different planetary boundaries, these functional boundaries, are interconnected, right? So they all relate to one another. Now, I know we're kind of focused on climate change, and as you can see, that's one of the functional boundaries here. And as you can see, as I said, this was updated as of 2020. I'm actually surprised this isn't a bit darker orange, but what they have done is they've put this arrow in to show the direction we're moving and that we are increasing our risk in these boundaries. Both this arrow represents this freshwater change and it represents climate change. You can also see that we're in sort of this uncharted territory in some of these other boundaries. And I want to set this bigger context because as I talk further here, I want you to think about how something like agriculture fits into these boundaries, right? So this biosphere integrity here represents the loss of biodiversity on the planet. And you can see here that we are in, some risky territory with several folks arguing that we may be in the midst of a sixth extinction. And think about that in the context of agriculture, right? Land system change. We're in the orange here. We're not in the red yet. And what this is representing is changing our landscape for human uses, right? So draining wetlands for urban development, for example, cutting down forests for grazing cattle, you know, as another example. Changing the form and function of a river floodplain so that we can grow food or build towns. So again, thinking of land system change, how that links to biodiversity, how that links to something like agriculture. Novel entities, we can see we're in the red here. And what novel entities mean is these are all of the man-made substances, chemicals that we put out into the environment. And we don't necessarily know what the consequences of that is going to be. And at this point in time, we have quite the chemical cocktail that we have released out into the environment. And we are starting to see the risks and the effects of that. But there is still a lot of uncertainty out there. Examples of this would be DDT, right? That was released into the environment and had some pretty severe consequences. A great example today would be plastics and how we're all dealing with microplastics now in our oceans, even in our own bodies and our tissues and the food we eat. So again, thinking of agriculture, all the different pesticides, herbicides, fertilizers, and industrial chemicals, all the types of chemicals that we put out into the environment. And the last one I do want to mention is this biochemical flows. So these are the natural biochemical cycles that exist on our planet. And what's represented here is the phosphorus and nitrogen cycles. And those have been massively disrupted through modern day agriculture. And we're really in some uncharted territory with the disruption of those cycles. And I know we've all heard about the dead zones in the Gulf of Mexico and those types of things. And so thinking about, as I move forward, just keeping this context in your mind, thinking about how these things are connected, how climate change is connected to biodiversity loss and how it's connected to fresh water. And then thinking about how agriculture and land use in general, how we use our land relates to what this is showing. And so this is not to cast doom and gloom or to get us all depressed right off the bat. But I want to set this context just for you to keep in mind as we move through the rest of the talk. These are just, challenges that we face, and we need to start, really working to find good solutions for. We can look at it that way. This is a really great simplified graphic. So I'm moving us down now into the one functional group of climate change, that one planetary boundary. So we're kind of narrowing our scope now. And we're going to look at climate change. And this is a great simplified graphic here from Project Drawdown. Maybe many of you are familiar with that. But it shows, it kind of breaks climate change down into this sort of equation, if you will, or this balance sheet. We have our beautiful atmosphere here in the middle. And then on the left-hand side, we have all of these inputs into the atmosphere, inputs of greenhouse gases. And what they're showing are different sectors of modern day society. And these are global scale numbers again. And what we can see are, various sectors contributing various amounts of greenhouse gases into the atmosphere. And then on the right-hand side, what we have are those things that are taking those greenhouse gases back out out of the atmosphere for us and bringing some balance to our equation. Unfortunately, we have this sort of big chunk here, this 59 approximately percent that is out of balance and remaining in our atmosphere, hence climate change. And what we have working for us so far are natural-based solutions. They are natural ecosystems that are doing this work for us for free. And so to help us balance this equation, what we need to do is we need to protect, first of all, through conservation, these wonderful natural systems that are drawing greenhouse gases out of the atmosphere for us right now. And then certainly through restoration, if we can bring these numbers up, that will help us balance that equation. On the other side of our equation, back to the left side, what we certainly need to start doing is bringing these numbers down. So increasing our numbers on the right side, decreasing our numbers on the left side to try and bring our poor atmosphere into a little bit better balance. And this is, all kinds of things, the choices we make, policy, the way we use our landscapes, all of these things are how, so many different things, approaches to helping us reduce these numbers. But for the rest of my presentation tonight, we're going to kind of live within this green zone here that you see, this sector of society that encompasses land use, food, and agriculture. And so certainly as I begin to talk about agroforestry, what agroforestry is seeking to do is reduce this number here from this sector and bring this down. And then on the other side, actually it seeks to increase this land sink number. So it is working on both sides of our equation. And so what is agroforestry? So this is a great definition of agroforestry. And essentially what we are doing with agroforestry, we have two basic approaches. So if I were to boil this down to its bare bones, what we are doing is our first approach is we go out on farmland or other open landscapes and we begin to integrate trees back into those systems. That's one approach. The second approach is we go into forest land that already has a forest ecosystem, a forest structure to it. And we start to intentionally cultivate crops into that forested landscape. So it's not about walking into the forest and foraging for some stuff and going home. It's actually an intentional cultivation of certain foods, medicines, materials that we would want from that forest ecosystem, known as non-timber forest products. So these are the two approaches we have in agroforestry. And what I want you to notice about this definition are these last three sort of goals, if you will, of an agroforestry system. So we have yields, we have ecological benefits, and we have ecosystem services. And within agroforestry, when we design it, when we put it on the landscape, when we manage it, each one of these goals is co-equal to all the rest. So we do not design or manage an agroforestry system just for yields, for example. We design and manage it for all three of these goals on the landscape co-equally at the same time. This is what makes it a very multifunctional type of agriculture. And this here is textbook Agroforestry 101. This is known as the 4 I's of agroforestry. And we use these 4 I's in one of 2 ways. We use these to help us identify agroforestry on the landscape. So there are many people out there that are practicing agroforestry, but they may not call it that. They may not have that vocabulary or that cultural context, but truly they are practicing agroforestry. So we use it to identify first off. Secondly, we use it to design and to implement new agroforestry practices on the landscape as well. And so I want to talk about these 4 I's because these really define what an agroforestry system truly is. So agroforestry systems are first intentional. We intentionally select specific crops, trees, potentially animals, all these different components of a system, and we utilize beneficial biological interactions to get this system to work for us for these multiple benefits that I spoke about earlier. Agroforestry systems are integrated. All of these different components that we intentionally select, we integrate into one system that is both that we structurally and functionally combined. So we're selecting species for their structure and also for their function within the whole system. Agroforestry systems are intensively managed. So these are perennial systems. They take time to develop, they change over time, and they require humans to be present with that system, to observe it, to watch it, and to change and adapt with it over time to keep these different benefits that we want out of the system in play at all times. And so they are intensively managed. It's not just about throwing some trees out into the back 5 acres and walking away and coming back in 5 years and hoping to have a bunch of fruit or nuts or whatever it is. And lastly, agroforestry systems are interactive. So all of the components that we've selected interact with one another to produce all these multiple benefits that we want. So the 4 I's of agroforestry. And I have to say, agroforestry is nothing new. Humans have used these types of practices for thousands of years around the globe. We have examples of all types of Native peoples using these practices everywhere, in China, in Russia, in Europe, in Asia, in Africa, all parts of the globe. These people have met their needs through these types of systems for thousands and thousands of years. What's new about this is the terminology that we're using today. It's the body of science and research that's developing around these systems, but the practices are nothing new. And certainly the Native peoples from our own region here, the coastal Salish tribes, have used agroforestry for thousands of years here in our own environment. And I'm citing a study here that came out recently back in 2021 about these forest garden remnants that they found around British Columbia that the Native peoples tended here in our area for, like I said, for many, many years. And what's cool about these systems, and as they've studied them, is they have found that not only did these systems meet the needs of the people that tended to them, provided food and medicine and materials, but they also found that the biodiversity of the entire surrounding ecosystem was increased when these forest gardens were implemented and were tended to. So really shows this relationship of humans being almost a keystone species within the ecosystem that they are tending these gardens in. So very interesting, a little bit different, perspective on how humans can be integrated into the landscape and still meet their needs. And I just want to mention really quickly a little bit about the scale of agroforestry systems. I talk about agroforestry to a lot of different folks, and a lot of the feedback I get right away is, oh, they sound great. These systems sound really interesting. I can see them working really well at a small scale, right? An acre, 5 acres, something like that. And yes, agroforestry systems work very, very well at small scales. They also work very, very well at large scales. It just depends on the type of practice that you are selecting. And so I will talk a little bit about the practices, and I will point out some of those that work well at a very large scale. So agroforestry can be scaled small, it can be scaled very large to hundreds, even thousands of acres. So with our current scientific body of knowledge that we have built around agroforestry and its systems, we recognize, or we lump most of the agroforestry that we see across the landscape into these 5 different practices, if you will. That's what we call them. And we have the practice of forest farming, of alley cropping, of silvopasture, of riparian forest buffers, and of windbreaks. And so I'm just going to introduce each of these practices to you, because what they show is what agroforestry might look like across the landscape, how we might implement it on our working lands. And so the first one is forest farming. This is the one I described earlier, where you go into an already established forest ecosystem and you begin to intentionally cultivate certain non-timber forest products that you want to get out of that ecosystem. There are a lot of foods and medicines that grow better in a forest understory than they do out in an open field. So again, this is nothing new. The native peoples did this. And these systems are very complex and have the ability to produce all types of things, while also providing all types of ecosystem services and environmental benefits. And this graphic is great because it kind of tries to capture some of that complexity and illustrate it, where you can see we can be producing fruit, nuts, herbs, medicines, seeds, mushrooms, root crops, teas, materials for building, all of these types of things. While at the same time, we are addressing things like climate change mitigation, food security. We have nutrient cycling in this system. We're increasing habitat and biodiversity. We are sequestering carbon and purifying the air. We are increasing water quality benefits and soil health. So these systems are really, they are an ecosystem that, like those forest gardens that those native peoples tended, that are producing all of these things. They're truly multifunctional, complex systems. Alley cropping. This is one of the practices that lends itself well to being large scale. And what we do with alley cropping is we go into farmland or other open space and we plant rows of trees with wide spaces between those rows. And we select our trees for an additional crop that we want. Maybe it's a timber crop, maybe it's a nut crop, maybe it's a crop that will provide additional food or forage for grazing animals or livestock that we're raising. So there are all types of crops that we can insert with our trees. And then between those rows in the alleys, we are continuing to grow the crop that the farm was already growing. So maybe that's grain, maybe that's row cropping, maybe it's corn and soy, maybe they're doing commodity cropping, maybe they are cutting hay for livestock. So all of these farming operations can still take place even when we come in and we insert these rows of trees back into the system. And then with that, when we get trees back into the system, we start to get a lot of these ecosystem services that come back. We start to increase habitat. We start to get all these beneficial soil interactions, and we start to build some of that complexity back into the system. Silvopasture, another one that lends itself well to being scaled up. And this, I just show a picture like this because I see this so often. I drive out around farmlands often, and you drive through, and I'm sure we've all seen this at some point. You're driving through big pastures, open pastures, and for some reason, there's that random tree that is out in the middle of the pasture, right? It didn't get cut down, it survived somehow, and it's out there by itself. And it's a hot summer day, or it's really rainy, and 9 times out of 10, where do I see the livestock? I see them right there under that tree. A lot of livestock like trees, just like we like trees. Trees are healthy for them. And so what we're doing with silvopasture is we are integrating trees back into pasture systems. And we have a big body of science and a growing body of science that is showing the benefits to livestock in a silvopasture system. They put on weight more easily. They produce more milk or more eggs. They have an easier time calving or kidding. They show less stress to the elements, of course, because they have this lovely shelter built in now. So trees and livestock are a really, really great mix, and we're learning more and more about that. And 2, when we integrate the trees back into this system, we are sequestering a lot more carbon and greenhouse gases. We are dealing with a lot of the manure and the inputs that the animals leave on the landscape and in the soils in various ways. These systems have huge benefits to livestock and huge ecological benefits as well. Riparian forest buffers are an agroforestry practice. And here in the Pacific Northwest, these are critical to the health of our rivers and our streams. And they are critical to the health of our fish species, to our salmon and all our other cold water fish species that we have. And these systems are critical to the health of the Puget Sound. And unfortunately, the scale of degradation of riparian forest buffers is outpacing the scale of restoration of our riparian forest buffers. Many, many miles of riparian forests travel through private lands. And so we need to incentivize private landowners to want to protect these systems or to restore these systems. And so this could be a talk all on its own, but some of the work that we're doing to help foster that is to show the benefits of harvestable riparian forest buffers. So these buffer spaces that provide that ecological function that we desperately need on our rivers and our streams, but also to be able to meet the needs of private landowners, a lot of those being farmers. And what do they need? They need space to grow crops to stay economically viable. So allowing these integrated systems, these buffers that also are able to provide a crop, a high value crop to the farmer, is a great way to incentivize more of these being put back on our landscapes and more of them being protected. I am, just in the interest of time, going to skip over windbreaks. They're also a riparian forest or not a riparian, but an agroforestry practice. They're pretty self-explanatory. So I'm going to skip over those really quickly. So, okay, just to pause here, we've talked about a lot. I first set that kind of global scale context and talked about some of the challenges we face and asked you to think about those challenges in the context of agriculture, right? And then we kind of moved down into climate change. And then I talked about agroforestry. We talked about what it is. We talked about how we identify it. We looked at what those different practices in agroforestry look like. So now what I want to do is I want to connect what agroforestry is to those challenges that I talked about initially. So agroforestry as a land use has the potential to not only be part of the solution to climate change, but be part of the solution to most of those other challenges that I talked about. And so how does agroforestry do this? And what is it showing us? What are we learning about agroforestry that leads us to believe that it can be part of the solution? And so to talk first about climate change and greenhouse gas mitigation. So this is a study that was put out looking at, these are again global numbers here, looking at different land uses. And we can see those land uses across the bottom of this graph here. And then on the left-hand side, what we see are gigatons of carbon equivalents that are sequestered per year by these various land uses. And we can see, grazing management, that's looking pretty good. Forest management, that's looking pretty good. We can sequester some greenhouse gases there. And then we start to look at agroforestry, and that really starts to kind of tower over some of the others. And one of the quotes that I pulled from this study was in the conclusion was, with even a modest level of adoption, agroforestry could sequester 2.2 gigatons of carbon per year, more than any other agriculture land management approach that we currently have. So that's significant. How much more carbon could we store if agroforestry were widely adopted? And the scientists actually took a stab at trying to estimate that, and we can see that we're really starting to tower over some of the other land uses when we get wide adoption with agroforestry. This is just in Washington State. Another graph, this was put together by Dr. Lynn Carpenter-Boggs from WSU. And she was studying what we call carbon farming. So there are these different practices within farming that farmers can implement on their land that are starting to show that they can help sequester carbon on farmlands as farmers adopt these different practices. And so Dr. Carpenter-Boggs listed some of those practices here along the bottom of this graph. And then again, on the left-hand side, what we see are gigatons of carbon equivalents per year. And then what she has on the right-hand side here are different counties within Washington State. And these different counties represent different climates and different soil types within Washington, because the type of soils and the type of climate and some of these variables, they play in to the amount of carbon that you can sequester. And so we see these different counties, we see these different farming practices, and we see about how much carbon they would sequester a year. And then she added trees into the mix. And we can really see that no matter what county, no matter what soil, trees really, really start to shoot us through the roof in carbon sequestration on our farmlands. And so to broaden this out a little bit, so we're starting to see that agroforestry has some real potential as a climate mitigation strategy. This study, I don't expect you to read this or make sense of this in any way. I will quickly explain this to you, what I'm trying to show. This was a study of a broad array of different types of land uses and land use choices that we make. And what they did was they studied these different land uses and land use choices against these 4 different buckets, if you will, or areas of concern. One of those is climate change mitigation. One is climate change adaptation. One is land degradation, and one is food security. So these were all challenges that these researchers wanted to address, and they were trying to find some of the best land use approaches to address these 4 different challenges. And they came up with this great, color-coded chart here. And what we're seeing is the dark blue represents the most positive effect that we can have across these different challenges. And then we have kind of our mid-range blue and our light blue, and then we have some negative numbers here. But mainly what I want to show is that there were very, very few land use approaches that had this high positive effect across all of these different challenges. And one of those, surprise, surprise, is agroforestry. A great benefit for climate change mitigation, as we've already talked about. Huge benefits for climate change adaptation, huge benefits for land degradation, and huge benefits for food security. So we can see agroforestry starting to broaden itself as a land use potential for meeting a lot of different challenges. Agroforestry and public health. This is a great study that looked at agroforestry and public health pathways and came up with this sort of acronym that they call MINER. And they showed that in agroforestry systems, because they're complex, because they draw on a lot of different species and integrate those into smaller spaces, they found that medicinal plants were protected, were conserved, and were propagated at a much higher rate within agroforestry systems. Income earned and input saved on rural lands, right? It almost doesn't matter what country you're in, rural communities have a harder time. And agroforestry systems adopted in rural communities can help increase income and can help reduce costs, especially on farmlands, where in agroforestry systems, we can show that we can reduce the costs of fertilizers, for example. We can reduce the costs of pesticides and herbicides and things like that. So reduce costs, income, money saved, money earned. Nutrition diversification. The nutritional profile available to a community where agroforestry systems occur is much more broad, it's much more diverse than where they are not used. Ecosystem structure and function is restored, it's regenerated, and provides all those benefits that we know of. Humans benefit from a healthy ecosystem, from a functioning ecosystem. And then the responses of these systems to meet specific challenges or needs of specific communities. So these systems are complex, they're diverse, and they can meet and be designed for very specific challenges. So they are very, very adaptable. We can go and design one of these systems for water quality concerns. We can go and design one of these systems for economic diversity concerns. We can design one of these systems to address land degradation, right? So they can be adapted and designed and are very responsive. Most of this I already touched on, production and ecological function at the same time on the same piece of land. Carbon sequestration, we talked about that. The soil health implications of agroforestry systems is vast, and I could do a whole talk just on that. The water quality benefits of agroforestry systems is huge. And then resiliency on our working lands. These systems are showing time and time again to be more resilient to so many different things, especially to extreme weather and climate events. And so how does agroforestry do all of these amazing things in this one land use? Well, this is a multidisciplinary discipline. Agroforestry draws from the science of agronomy. It draws from the science of forestry. It draws from the science of ecology and the environmental sciences. It draws from the social sciences of anthropology and of sociology, and it draws from economics. So because it has all these multidisciplinary bodies of knowledge to draw from, it can create these complex, very multidisciplinary, very diverse systems that can be very adaptable. And it can address things like markets, like biodiversity, like improving livelihoods, climate change. It can address all of these different aspects, social, economic, and environmental. And so thinking about agroforestry back in the context of that very first slide that I showed, right? I'm not saying that agroforestry alone is going to solve all the world's problems, but it is an approach, it is a land use that has a lot of potential in a lot of different things. And so it is a land use that can address many things at one time. So just to summarize, we have many interrelated global scale challenges, climate change being about one of those. The way we use our land is a major contributor to those challenges. We all eat. The way we grow our food and meet our needs on our landscapes contributes to those global challenges. So are there solutions that are available now that can start to move us in a different direction? And agroforestry is one of those. It's available now. We have the technology now. It's relatively low cost, right? It'd be great to have more investment in it, but we don't have to wait for some technology to be invented and then invest billions and billions of dollars to get it up and running. Agroforestry is a land use solution that we have available now for relatively low cost to address many different concerns. Potential as a land use for producing food, medicines, a wide variety of things for humans, to renew degraded lands, to restore and protect habitat and biodiversity, to help working lands adapt to a changing climate, and to be one of those pieces of climate change mitigation as well. So if you're interested to learn more about agroforestry, these are a few resources. My own program there, and at that website, Agroforestry Northwest, and then the USDA Agroforestry Center, and the Association for Temperate Agroforestry. These are all great places to start. You're also always welcome to contact me. I love to talk about agroforestry. I can always give you more information or answer any questions for you if you're interested. So that is my contact information as well. And then that is all I have.
Thank you so much, Carrie. That was a really fascinating talk. And I know I certainly learned a lot about agroforestry and the amazing benefits it has for climate change. So thank you so much.